Hi, everybody. Glad to be here with you today. And we're going to talk today about something that's an important topic as we move into dealing with multi cloud deployments and management, and that is leveraging abstraction automation to manage multi and hybrid clouds. Well, first, I'd like to thank Keith Townsend and his group for allowing me to speak to you today. I'm really looking forward to presenting this topic. So let's get going. So, this is what we're going to talk about today. The term is beginning to emerge, such as supercloud, distributed cloud, metacloud, and abstract cloud. And really, we're getting to the point where we're dealing with these very complex deployments, multi cloud, hybrid cloud being kind of the center point of the ground zero of that. And so, what we're doing is figuring out ways to simplify how we're going to manage and monitoring these deployments. And that's where abstraction and automation comes in. And that's going to be really the focus of this presentation to tell you what abstraction and automation is, what role it plays in terms of dealing with multi cloud and hybrid cloud complexity, and how you can deploy this stuff today to make your hybrid cloud and multi cloud deployments much simpler to manage, much simpler to leverage. So first, let's define the problem. So why are we dealing with abstraction automation? Well, it's a reaction from the fact that cloud implementations, as I mentioned earlier, are becoming way more complex. We'll get into the reasons of that because I think it's important to understand how we got to this complexity state and why many enterprises are hitting a complexity wall. In doing so and understanding how the problem's occurring, it's much easier to solve the problem. So I do recommend that you not just take my general guidance here as to what the problem is, but look specifically at your problem domain into what problems you're dealing with locally. So the increased complexity is causing some negative value from the cloud deployments. In other words, people are putting in $2 investment in cloud computing, and they're only getting $1 back. And they're receiving much higher cloud bills than they thought they would. The deployments are much more expensive. Operationalizing these systems much more expensive and risky, and they're even sacrificing things like security risk at the altar of complexity, and really need to start moving in different ways in how we're dealing with this technology. So the movement to hybrid and multi-cloud is really kind of only accelerating right now, and so as we're moving forward, this is only going to get worse. And we're going to create more complex problem domains based on the way the technology is built. So that's going to be systems that are able to communicate with legacy systems, edge-based computing, the growth of that technology, mobile computing. All that really comes into the domain of multi-cloud and hybrid cloud deployments. And that's why we have to deal with the complexity problem when dealing with this. So complexity, keep in mind, is a natural progression of IT. We deal with platform complexity. In other words, we went with mainframes for a long time because that's the only thing that was available. Then it was mini computers, and then it was PCs and local area networks, distributed systems, Intel core-based systems, all these things which really kind of evolved over the years. And moving from centralized, distributed, remote, things like that. Databases, we don't leverage a single database for every purpose, even though databases have the common patterns. They store and retain information. But we have object-based databases, relational databases, proprietary databases, all these things which kind of make up the infrastructure. And as people deploy different applications and leverage different best-of-breed technology, they leverage whatever database they need to leverage. Same with programming languages. We don't program the same way we did 20 years ago and won't in another 20 years. Same with security, same with management and operations, and then architecture as well. So we went from no architecture to some architecture, structured, object-oriented, service-oriented, cloud microservices as we kind of are today, into kind of a multi-cloud deployment. So that evolved over time. So this is kind of how complexity occurs. It's a natural progression of IT because we're always rethinking better ways to solve the issues, better technology, better approaches. And that creates layers upon layers of different technological solutions, which leads to the complexity problem. So how did things get this bad? Well, different sprints, different teams, decoupled thinking, no centralized cloud services defined. So in other words, we don't have a common set of cloud service security services or governance services or management and monitoring and FinOps services. Lack of single security approaches, as I mentioned earlier, single governance, lack of retiring existing legacy applications, and really kind of lack of planning that it kind of came around this. So understand that we didn't get here by accident. It's kind of by design. And If you look at the way in which we develop things out there in the world today, we have different pods that are different and are existing independently of each other. They make decisions on their own thread. And so they pick their own technology, their own best of breed stuff, their own way of doing it, therefore their own cloud providers. And that's how things got complex. So in other words, it's the abundance of choice kind of mixing the fact we have all of these decoupled development systems, development teams that are building these things. We want this to happen. We want to have the most creative and innovative teams out there that are building technological solutions for the business with the best technology that they can find. But that is going to have some downsides, and the downsides in this case is going to be complexity. So the assumption is enterprises are going to focus on small layers of dissimilar cloud architectures. They're going to carry out short sprints in doing it, and they're going to lack common services and common holistic architectures in making that happen. We have to make that assumption because that's the only way it's going to happen. It's very difficult to rein this in and say, hey, everybody is using multiple clouds and multiple databases and multiple platforms. You have to leverage the same database, the same platforms, and the same cloud providers. That's going to limit the solutions or the ways in which you're able to build these systems. And that's going to return less value back to the business. That's not going to be acceptable. So this is a way in which we're assuming things are moving forward. So the problem is we're going to hit a complexity tipping point where the number of cloud-based systems, the number of on-premise systems, complexity is going to start to grow. And basically the number of systems is completely dependent on the growth of complexity. And we're going to hit a tipping point where we're going to have negative value that comes back to the business. The idea is not to avoid hitting that tipping point. The idea is to have a plan around and mechanism around minimizing the impact on that complexity tipping point that every company is bound to hit. They're hitting this now, and what the industry is calling it is a complexity wall, and you hear that out there a lot of times. The AI ops vendors are touting that, and we can do a couple of things. Number one, change policies and platforms to try to avoid it, which I just mentioned earlier, not typically acceptable, or figure out better architectural practices to manage through it. And kind of that's what we're learning here today. And this is the problem with the tipping point. You get negative value. As I said, we have in some of the studies that were done in 2022, there was a huge ROI deficit that's coming back from the cloud-based deployments that we're seeing. So in other words, they're spending a lot of money, say $10 million on a cloud deployment, and they're expecting maybe $40, $50 million to come back in return on investment and measurable value that comes back to the business. And it's not. It's actually much less value that's coming back to the business. The costs are higher. The amount of talent is needed, the skills that needed around to support it were really kind of unexpected. And then we're hitting the complexity wall, not only in terms of basically complexity hindering return on investment, but it's actually returning negative value back to the business. And right now the boards of directors are asking about that. So in other words, we said that cloud was going to have this tremendous advantage and return value back to the business. We're seeing much higher costs, much higher risks in deploying cloud computing. Why is that happening? How can we mediate that complexity? Again, purpose of this presentation. So what needs to be done? Well, the solution in the nutshell is dealing with complexity management. And dealing with complexity on your terms, not complexity's terms. And the two, there's lots of different architectural approaches that you can see and how you're going to deal with complexity. But the two most popular are going to be automation and abstraction. We're going to get into those in detail. And automation means data movement, data processing, service processing, abstraction of data, abstraction of services, abstraction of platforms, knowledge, AI, security, development, etc. Those are things that we can simplify through the abstraction process and automate through the automation process to make them much easier to deal with. So in other words, we're able to deal with these things with fewer resources. We're able to make them much more valuable. We're able to deal with them through simple abstract concepts, and also, in essence, leveraging resources as a true force multiplier. We're able to use less skills, less money, less time, less risk in dealing with these very complex platforms we're deploying these days. This comes down to complexity management. It doesn't matter what you call it. The outcome is typically going to be an abstract cloud. We'll talk about that, supercloud and metacloud, later in the presentation. But the idea is to kind of understand the basic problems and how we're fixing the problem. In this case, automation and abstraction, what those are and how they work. So an example of data abstraction would be dealing with complex data. heterogeneous data stores. We have stuff in object databases and relational databases and proprietary databases and in-memory databases and purpose-built databases, maybe data that's sitting on mainframes and in old common delimited systems. And we have to make use of this data in some way, shape, or form. And so the idea is we deal with that data using layers of abstraction or virtualization, where we can make all these various physically dispersed, disparate, heterogeneous databases look like a single unified structure that's more related to how we consume and how we leverage the data to bring value back to the business. That's the idea behind it. So instead of me having to make independent calls using whatever native interfaces are going to be there to communicate with all the various databases out there, heterogeneous databases, all shapes, sources, kinds, and brands, I'm looking at an abstraction layer, in this case, data virtualization, which, by the way, has been around for 30 years. It's nothing new, which is able to simplify how I'm seeing the structure of the data, how I'm seeing the data unto itself, and therefore able to consume the data into applications, into dashboards, or even through analytic systems to be dealt with interactively by humans that are able to leverage the data in a much better way, shape, or form. So an example would be common access to providing Salesforce forecasting analytics. We have a unified dashboard, which is a data service manager, which is able to deal with virtualization and master data management systems on either end, which is able to deal with the actual physical databases on the lower level. So relational databases, object databases, columnar databases, unstructured data, many instances could be just a file farm of PDF files, and then legacy information or non-cloud data. So the idea is that we're able to take these physical structures, abstract them through the system to make them simplified unto themselves, and able to consume the data using whatever structures, whatever metadata, and whatever views that we want to have of the data that's going to be independent of the physical complexity of the underlying very heterogeneous, very complex data sources that are coming from. And so that's the idea behind data virtualization and data abstraction, which, by the way, is not a new concept. I wrote about it in my EAI book back in 1990s, and it was well understood then, and it's well understood now. And there's a lot better tools out there to make it happen. So service abstraction is the ability to things that basically things that do things contain behavior. In other words, they actually are services that instead of providing information, they provide behavior to us. They provide an action to us. So we're going to delete data. We're going to move information from one point to the other. We're going to calculate a risk analytic system. We're going to basically define something that's going to be behavior that's defined programmatically, typically, which is going to be contained within a service, which means when we evoke that service, we carry out that behavior. It may act upon other services and other databases and other data sources, but unto itself, that service is a self-contained unit of behavior. Examples would be web services, APIs, or other interfaces that make things happen and contain an application, data, and devices. We've been using services for a long time. Certainly within APIs is a very old concept. Service-oriented architecture, we're kind of based on services. And now moving into cloud, everything's kind of based on services, whether they're application-based services, platform-based services, security services, governance services. We contain these things as services, so we're able to reuse them from one application, one interface to another. So an example of service abstraction would be complex services and microservices, and they're heterogeneous. So in other words, it could be running all over the place, different cloud providers, different systems, different applications, different platforms, and we're able to use service abstraction, which is either able to leverage many services as an abstract service or basically a meta service. So we're defining something as a composite service, which is leveraging all these various native backend services to create the composite service, and we may add additional features and functionality to the composite service. An example would be doing a credit check. We may have one service that will pull a social security number, another service that actually reaches out to the credit check database, another service that actually performs the credit check, but we put it into a master macro service that's called credit check, and it carries out all those three services on our behalf. And therefore, it removes a lot of the complexity from dealing that. We also have the ability to orchestrate services, which means that we're automating invocation of services from one service to the next to carry out some sort of a business process. And by leveraging these kind of layers of abstraction, we're able to simplify how we're dealing with services. And this is where abstraction really kind of earns its money. It's making simple things out of very complex things. And we're able to use these services in a much more productive way that's going to remove the complexity and therefore remove the cost of operations. That doesn't mean that we couldn't do the application by leveraging all the native services individually and not leveraging abstraction. That would certainly work, but it would take a lot more time. It would take a lot more money. It would cause a lot more risk to basically moving that process. So we're doing things smarter rather than harder by leveraging abstraction to automate and simplify how we're interacting with those services. The challenge of this would be service granularity. So the trick of building composable services is how you deal with the level of granularity. And that just kind of means on what the services do. In other words, are they very discrete services that carry out a very small function, which typically microservices do? Or are they more of a coarse grain function, which may carry out a large, which may carry out a more complex service? For example, as in our previous example, we had, doing a credit check, and one of the microservices we could leveraging is, say, validate the social security number. That would be an example of a fine-grained service because it's doing something fairly discrete, versus the macro service, or basically the one service that's made up of all the other services to determine what a credit check is. That's going to be more complex. That would be more of a coarse-grained service. So the challenges are integrating business logic into code and decomposing legacy services, that are not fine-grained enough. Top-down process decomposition, bottom-up service development. Ultimately, this must be interactive. So the trend today seems to be when in doubt, break it out. And so the reason we go from coarse-grained to fine-grained services, which are really microservices, is the primary instance of that, is because we have more flexibility with them. So in other words, if we don't break out a service and we have it kind of bound to this thing that it's hard coded to do, we can only use it to do that hard coded service, versus microservices, which could be hundreds of services that make up some sort of a functional business process. We can leverage those either all together as composite services, configured to the way we want, or leverage each individual microservice, and therefore it provides us with the flexibility of leveraging those systems. Hopefully that made sense to you. Example, services sold on demand by health data companies. We have unified data access dashboards, dealing with a service manager, service virtualization. In other words, we're leveraging composite services. And we have microservices, fine-grained services, coarse-grained services, cloud services, legacy services. The idea is that we're able to take these services and orchestrate them, take these services and abstract them, take these services and automate how we can move information, or basically automate a business process in between these various systems, which is leveraging these services on our terms and not having to deal with the complexity of the services themselves. So orchestration drives automation. You hear about automation. Typically, orchestration and automation are going to be hand in hand. It controls action or sequence of several heterogeneous resources. Service could be data movement, things like that. Any number of things that we want to do in sequence, or some sort of a logical order, or some sort of area where we're able to program the behavior from a meta process standpoint. And the ability to leverage to abstract you away from the complexity, considering that they provide the ultimate control mechanism. We're dealing with orchestration. Everything's at a configuration level. We're not having to reprogram the services for each and every job and activity that we do. We're able to basically create the orchestration layer that's able to sequence the services and however we need them sequenced to do whatever they need them to do, to basically provide the business automation that we need to support the business in whatever way. And we're able to do so in a very simplistic way. So we're able to create automation between services in a matter of minutes, sometimes minutes, sometimes hours, in more complex processes, versus if it's a programmatic approach where we have to change all these backend services to automate these things, or even create a composite application to do them using a native tool. That's going to take a much longer period of time. You're going to have to test it, deploy it, things like that. So we're able to put volatility in the domain of the orchestration layer, and through orchestration and reorchestration of these systems, able to order and reorder how they're able to solve the particular business problem we're looking to solve. So let's talk about moving to a solution. So the approach is automation of abstract resources. That's what we're getting into, typically leveraging orchestration. We have step one, step two, step three. Those are the steps in our orchestration layer. In this case, we're doing it in sequence, but we may have loopback procedures or other logic that may bounce us to more complex orchestration platforms where we leverage orchestrations that may kick off other orchestrations that are nested. They kick off other orchestrations that are nested. The idea is we're not typically building an application. We're just invoking services and invoking data movement that's able to turn our orchestration into a business solution that's able to fit the needs of a particular business. In this case, service invocation 1, Oracle database, service invocation 2, Windows NT-based system, service invocation 3, which is going to be a Linux system. So the idea is we have an invoker, which basically says, go, kick it off. We are able to read data from different databases, access data, send requests, consume result sets, able to process data, validate data, apply rules, return results. So the idea is we're able to do things at a much higher macro level, at an abstract level, using automation, in this case orchestration, to make it happen, which pretty much is what you're going to use all the time, at least conceptually, to solve this particular problem, but do so through a hierarchy where the complex things are going to be kept down and lower in the hierarchy and typically aren't going to be changed, but we make the changes at the higher level or the orchestration level. So we even can abstract AI, and we're going to put this on there because AI is kind of a big concern right now, and I think people want to know how to leverage AI effectively. So learning frameworks or AI can be abstracted and automated, just like anything else we just discussed. At the end of the day, they become data sources and service sources. So we're able to take knowledge engine that may or may not be a part of your multi-cloud or hybrid cloud domain, but most of them are going to be. There's always going to be an AI component to most multi-cloud deployments. If it's not there now, it will be soon. Cloud-based and linked to many applications and data stores. And we're able to get to the reusable knowledge engines that can be managed using abstraction and automation. So the idea is that we're not building a knowledge engine for each purpose that an application needs, but common knowledge engines that are able to operate across applications and across operational data views. And that's one of the better ways to manage this kind of resource. Got to remember, AI systems are pretty expensive. And so the more we're able to make their usage efficient and less complex, the more value that they're able to bring to the business. And that's including generative AI systems like Chat GPT and other kind of emerging AI systems that are providing additional value to the business. So looking at abstraction automation to leverage those kinds of systems in much the same way to eliminate the complexity issue and get to the value in those things. So how it works, we're able to take cognitive and abstraction automation. We're able to deal with knowledge-based entities, engines. So we're able to take, for example, entity A could be, could be a simple traditional AI system that's, leveraging supervised training. The other one can leverage unsupervised training, entity B, and the other could be a generative AI system. All leverage data. So in other words, they're looking at information, they're taking data as training data, and they're turning that data into knowledge engines that can be abstracted and leveraged by the applications. And so we're able to leverage these systems through a cognitive abstraction automation system, which is able to manage the views and the visibility into these various knowledge engines. So we're able to better manage the purposeful use of those knowledge engines for databases, for queries, for human interaction, whatever we need to make it work in the business. And so we're not having to deal with the complexities of going down to each native engine each time we want to leverage it and therefore learn and deal with the native engine on the terms of that native engine. We're able to deal with that native engine on our terms that are basically leveraged by the abstraction layer, in this case, cognitive abstraction automation layer, that you're able to leverage. Orchestration can be a part of that. Anything that's able to look at all these various native systems, abstract them into much more simplistic concepts. We're doing nothing different here. So an example would be health diagnostics and telemetry. So we have Amazon SageMaker, which is able to communicate with patient data as training data. Microsoft Azure Machine Learning Studio, which is also able to look at patient data as training data. And Google Cloud Machine Learning Engine, which is able to look at outcome data and diagnostic data as its training data. And we're able to leverage an abstraction automation system to see into these various heterogeneous systems. These are all different. They all use different native interfaces. They all use different APIs, but do so through a common abstraction layer. We're able to deal with each of these things using the same conceptual view of what a knowledge engine should bring and be able to ask questions and have it manage how those questions can be processed. So by doing this, we're able to replicate the value in each three of these knowledge engines into a single knowledge engine. So therefore, we're able to accelerate or basically leverage this cognitive abstraction automation layer as a force multiplier to get more value out of these three knowledge engines, these three AI systems. So we're leveraging this to not only reduce complexity, but also manage and deal with these technologies in better, more productive ways. So now we look into the applications of supercloud, metacloud, which is kind of where all this is going now. So if you think of what this all means is that we're looking to put complexity into a domain, leveraging abstraction automation. So we're not necessarily dealing with the native systems, in this case, a multi-cloud deployment, on the terms of every cloud provider that's out there. We're dealing with those things on our terms. So we're dealing with how we're dealing with security and how we're dealing with governance and how we're dealing with management and operations and how we're dealing with FinOps, not at the native levels of each cloud provider, but doing so at a larger abstract layer. And in doing that, eliminates the complexity challenge because we're not dealing with the redundancy and the heterogeneity of having to deploy across multiple cloud providers. And it could be as many as 5 or 6 in many enterprises, which is hugely complex, and moving from 1,000 services under management to 10,000 services under management that are heterogeneous and have all their own terms and rules and how you deal with those services. So the idea is to put that complexity into a single configurable domain where we're able to leverage automation and abstraction to simplify how we view those domains. I think that we've beaten that mule enough at this point. So we're able to leverage this thing called a metacloud, supercloud. I don't really care what you call it. Ultimately, this is the ability to create cross-cloud services like operations, security, governance, development, deployment, service management, service brokerage. You can kind of read those up there on the screen. Integrated AI, as we just discussed, data integration, et cetera. Out of all these various cloud providers, by picking common services, they're able to operate across those cloud providers. So instead of picking the native security for Cloud A, we're able to pick a security system that's able to run across the cloud providers. And by the way, that can run anywhere. It can be run on your on-premise systems or on a particular cloud provider, it doesn't matter. But logically, this sits above the cloud providers and is able to communicate with each cloud provider using its native interfaces instead of you having to deal with each of those cloud interfaces on their terms. You're dealing with one security interface in this instance that's able to carry out any kind of native capabilities using translation into those native interfaces that it supports. So security managers that operate cross clouds. AI ops for management and operations, application development services, federated container orchestration that's starting to emerge. Service brokerage systems that operate across cloud, cloud management platforms, security managers, data integration systems that operate across cloud. All these things are emerging now and basically become components of what exists in a cross cloud service, which becomes your super cloud, meta cloud, and that's kind of where all this stuff is going today. So hopefully that made sense. This is an important topic as we start moving into these next generation cloud architectures. Complexity is going to be a challenge, and the ability to deal with complexity and manage complexity is also going to be a challenge. And so I urge you to kind of understand what tools and weapons you can have in your arsenal out there to kind of take your architectural game to the next level. I suspect we'll have many multi-cloud deployments that fail over time because they're not able to deal with a complexity challenge by using these techniques we just presented in this presentation. However, you can get ahead of the game. You can kind of understand how the value is going to change the way you do your architectural planning and start planning to deal with these challenges before you have to deal with them and they become something you have to basically do battle with when the complexity challenges come up. It's much easier to plan and deal with them in a proactive way. So I urge you to do that. Well, anyway, thank you very much for attending my presentation. I enjoyed talking to you, and please reach out to me if you have any additional questions. Thank you very much.
As promised, wasn't that a great session? If this is your first session of the day and you're wondering what's next, well, you have options. You can hang out in the chat room now. You can see there's a conversation going on in the chat room in the session that you're in. This will be open until the end of this hour, and the top of the next hour, the next session will start. If you want to go into the breakout room, there's a general chat session. You leave here, go into the lobby, and then enter general chat. You can chat with your regular attendees. I'll be floating between the two chat environments. Love your feedback. If you have any questions, please, you can DM me within the platform or on Twitter at CTO Advisor. Enjoy the rest of the conference.